Hi, welcome back to another video. In this video, we are going to be talking about measures of dispersion, okay? So a measure of dispersion tells you how spread out the data is. And for the formal definition, it is used to describe the spread of data items in a data set, all right? So it's telling you how far spread out your data is, like the range of numbers that it covers. And so speaking of range, the first measure of dispersion that we're going to use is the range. Now the range is equal to the difference between the highest and the lowest data values in a data set, and it indicates the total spread of the data. So if you want to find the range, you would just basically take the highest value minus the lowest value. Alrighty, so here's just a simple example to show you how to find the range. So this example 1 says find the range of the data set that contains 11, 13, 14, 15, and 17. So I want to figure out what is my biggest number and what is my smallest number in this data set. So the biggest number is 17, and see, this one is in order, so it's easy to find the biggest and the smallest. But not every data set is given in order. So since the biggest number is 17, then I will do 17 minus the smallest number, which is 11, which gives me 6. So that means that the range of this data set is 6. That's how far spread out that the data set is. It spans over 6 numbers basically. And so that's what the range means, and that's one measure of dispersion, okay? Now there's another measure of central tendency called standard deviation that's used quite frequently in statistics. And the standard deviation is a measure of dispersion depending on all of the data items. So if you notice with the range, you only use the biggest and the smallest. Well, standard deviation is a measure of dispersion that usually uses every number in the data set. And it's found by determining how much each data item differs from the mean of the data set, okay? So there are a lot of steps to finding the standard deviation. But first of all, let me just show you the formula for the standard deviation. So I'm going to use S to represent standard deviation, and it's equal to the square root of the sum of x minus x bar, which if you watched the previous video where we talked about calculating the mean, the x with the line on top is the mean. Alrighty, so the standard deviation is equal to the square root of the sum. This is the summation symbol. That means you want to add up all of these things right here. So the difference from each data set and the mean squared, you want to take the sum of all of those and then divide it by n and take the square root of it. Okay, so the formula is a lot going on in the formula, and so that's why we're going to break down the standard deviation step by step, okay? So there are 6 steps, and I'm going to take you through an example and show you how to use each of the 6 steps. Alrighty? In this example, we want to find the standard deviation of the same data set that we had in the last example. So 11, 13, 14, 15, and 17. So this is just a small example to show you how to go through each of the steps to find the standard deviation. So the very first step of finding the standard deviation is to find the mean of the data items. So I need to go through and figure out what is the mean of this data set. And so remember, to find the mean, you have to add up all of the numbers and divide it by the number of numbers. So that means I need to add 11 plus 13 plus 14 plus 15 plus 17. I need to add those all up. And when I add those all up, I get a total of 70. And so in order to find the mean, which is x bar, it will be 70 divided by the number of numbers, and there are 1, 2, 3, 4, 5 numbers. So 70 divided by 5 is equal to 14. So the mean of the data set is 14. So this is step 1. Step 1, remember, is to find the mean of the data set. Alrighty. Now step 2. Step 2 is to find the deviation of each data in the set, each data item, from the mean. So for step 2, what we want to do is we want to figure out what is x minus x bar. We want to figure out how does each data item differ from the mean. So in order to do this, I want to create a table. So I'm going to go through and create a table. I'll bring it over this way some. And I'm going to list each data point. So that's my 11, 13, 14, 15, and 17. So that's every data item, right? So for step 2, so here's my step 2. I want to figure out what is x minus x bar. So I need to figure out what is 11 minus 14, because 14 is the mean. Well, that's negative 3. What is 13 minus 14? That's negative 1. What is 14 minus 14? That's 0. What is 15 minus 14? That's 1. And what is 17 minus 14? That's 3. So that's how you figure out how each data point differs from the mean, okay? So that is step 2, and so I'll write step 2 here, but I'll draw an arrow here because this is what you're doing for step 2. You're figuring out what is x minus x bar. Alrighty. Now step 3 is you want to square each deviation. So step 3 is actually gonna be x minus x bar squared. So basically you're just taking each of these numbers and you're squaring it. So this is your step 3 right here. Step 3 is going to be to take each of these x minus x bars and square it. So we're going to take each of these numbers and square it. So the first one is negative 3. Negative 3 squared, that's the same as saying negative 3 times negative 3. That's positive 9. Negative 1 squared, that's negative 1 times negative 1. That's positive 1. 0 squared is 0. 1 squared is 1. And 3 squared, which is 3 times 3, is 9. Okay? So that's step 3. You square each deviation. So that's taking each data item, x minus x bar, and squaring it. Alrighty? Step 4 is you want to take the sum of the squared deviations. Okay? So step 4 is here. Step 4, you want to take the sum. Let me write it over here some. So step 4 is you want to take the sum, that's my summation, of x minus x bar squared. Well, this is my x minus x bar squared column. So what I want to do is I want to take the sum of this column. So 9 plus 1 is 10. 1 and 9 is 10, 10 and 10 is 20, or 9 and 1 is 10, plus 1 is 11, plus 9 is 20. So that's 20. So for step 4, this is equal to 20. The sum of the squared deviations is 20 in this case. And that's just taking this last column right here that I have and adding them all up. That is step 4. Alrighty, now for step 5, we want to divide the sum in step 4 by n minus 1. Where n represents the number of items in the data set. So in this case, our n is equal to 5 because we have 1, 2, 3, 4, 5. It's the same thing we divided by here. That's your n, okay? So for step 5, we want to take this sum that we got here, 20, or let me write it out first. We want to take the sum so you can see where it fits in the formula. We're going to take the sum of the x minus x bar squares and divide it by n minus 1. Well, the sum of the x minus x bar squares is the 20 we got over here. And we want to divide that by 5 minus 1 because our n is 5. 5 minus 1 is 4. 20 divided by 4 is 5. So that's the answer for step 5, okay? So even though I'm circling these aren't my final answers. That's just the result from each step, okay? And we have to go through these to get to the final result. All right, now step 6 is to take the square root of the quotient in step 5. Okay, so we already divided it out. It was a quotient when it was 20 over 4, but now we want to take the square root of that. So for step 6, we will just take the square root of that answer. But let me write it out in the formula so you can see. Let me write it out so you can see where it is in the formula. Y'all can't really see that good down there. I'm gonna write it in this little space right here where y'all can see it. So for step 6, what we want to do is take the square root of x minus of the sum of x minus x bar squared, all divided by n minus 1. So that's actually your formula for the standard deviation. But we now know what the inside of that square root is because that's the result from step 5. So for step 6, we want to take the square root of 5. And that gives us our standard deviation. The square root of 5 is actually, if you round it to the nearest hundredth, it comes out to 2.24. So in this case, that right there is our final answer, okay? Our final answer is that 2.24. That is your standard deviation, and that tells you how spread out the data is. That gives you an example of how spread out the data is. It says that the data is approximately spread out by 2. Not an overall spread, but spread it individually, okay? So just to kind of recap what we did, for step 1, we found the mean of the data set. We found that by adding the numbers up and dividing it by the number of numbers. So that's where we got the 14, the X bar. Step 2 was we had to take each data set and subtract the 14 from it. So we did X minus X bar and we got these values. For step 3, we had to square each of those values. So you take those numbers and square it. Step 4, you add all of those together. Step 5, you take that number and divide it by n minus 1. So 1 less than the number of data points. So we divided that by 4, we got 5. And then step 6, you just take the square root of that number and that gives you your standard deviation. So that's just basically taking the formula for the standard deviation and breaking it down step by step, okay? So you may have to watch this, rewind it, and watch it a couple times to get it because it is a lot of steps. So do what you need to do. If you need to rewind it back and walk through it with the problems that you have to work for your homework, then do that. And then if you have any questions at all throughout that process, don't hesitate to put them in the comments or send me a personal message. So thank you for watching, and I will see you all in the next video.